All right, multiple regression. This is another multiple regression scenario. Right now, we have three independent variables, the given dependent variable, right? In this particular multiple regression, you have three independent variable, but technically, even though you include this x1 and x2, you're not very interested in x1 and x2. You are interested in the effect of x3 onto y, what? And after control for x1, x2 as including as an independent variable. Are you with me? One more time. In this case, we have three slopes and then three independent variables. But we are not very interested in x1, x2 effects onto y. We are interested in effects of x3 onto y after control for x1 and x2. This research question is very different, whether which one is you are actually care about it, right? And which one is, even though three variables are independent variable, which is main independent variable you are interested in to evaluate the effects, or the other two independent variable, you just use it as the controlling purpose, right? So let's move on to SPSS, how to do this one. All right, we still have 1, 2, 3, 4 independent variable, right? Analyze, regression analysis, linear regression. In here, let's say we don't have any independent variable. Dependent variable you included as gain. And then you included independent variable. First two independent variable, right? x1, x2. Again, we are not even though we included x1, x2, we are not very interested in x1 and x2. And then you are interested in the effect of x3, but in that case, you are blocking those two control variable as a first block. See, block 1 of 1. Next, technically you have oh, where's my independent variable? Where my independent variable go? Well, you have it in here, right? Click next. You're setting up second block. There's two blocks. And the second block of the second block, you're including third independent variable. Methods enter as a default, right? If you click OK, you're able to see this particular regression result. Descriptive statistics, exactly same as a simple and x1, x2 case. I don't want to repeat again. Again, correlation, same thing. Correlation between x1, x2, x3, and all bivariate correlation. I don't want to repeat that one anymore, right? But please be carefully take a look and in here. See, we have now two regression models. First regression model is dependent variable on what? x1 and x2 only. And the second regression model is what? x1, x2, and x3. This is not like the second model is only for the x3. This is actually what? On the top of the previous one. x1, x2, and x3. One more time. The second model, x3, is entered on the top of the first model. So you're making your model is more complex, right? So third model includes both, all in the x1 and x2 and x3 independent variable. Another one, a model summary. Because you have two different model, again, what are two different model? First model, only for x1 and x2 as independent variable. Second model, you have three independent variable, x1, x2, and x3, right? So two different model, R-square value. Look at this. R-square value for the first model, which is x1 and x2, was 0.31. So only 31% was explained. Well, not only, but 31%, approximately 31% of dependent variable variability explained by your regression model, the first regression model, only with x1 and x2, right? Model 1. Model 2, nearly what? 40% explained. See, the difference between this one is what? Nearly 9% of what? Amount of variability explained by, additionally explained by third variable. Are you with me? So people, we will talk about those things, and what difference between this R square value and in the second model and first model, and then you're able to see the what is additional statistical explainability gained by entered the second model, additionally entered the independent variable. Okay, another table as well. For example, this is regression model, sum of square regression, residual total. Degree freedom is 2. Why the first model degrees of freedom is 2? Because you enter only 2 independent variables. Likewise, you have a sum of square regression for second model. You have a 3 degree of freedom. What do you mean by 3 degrees of freedom? You have a 3 independent variables, right? Both model happen to be what? Statistically significant, right? This model is also statistically significant, and this model is also statistically significant, right? Coefficient value, same thing, right? And then you can interpret, well, this third independent variable is what? Also statistically significant. I mean, not also, but statistically significant after control for x1 and x2, right? And this is exclude variable, collinearity, whether model is, which model was excluded. Technically, model 1, you don't have x3, right? So this is actually, right now is a very boring interpretation, but this is actually how you play around to adding additional independent variable by blocking option. But next question is, given x1 and x2, x3 at the same time, and you want to know whether those x3 is the R square value is nearly changed as a, like for example, 9%, right? 9% type of thing, right? Nearly 10%, right? But whether that 10% is statistically significantly improved or not, one more time, whether those statistically third variable in terms of R square, nearly 10% change, right? 10% change, right? Whether that 10%, 9% is what? Statistically significant or not, that could be a very good research question, right? Let me tell you how to do that one. Right now, it's very hard to see whether this additional statistical explainability itself, which is nearly 9%, improvement to R score, is statistically significant or not. We cannot clearly see that one, but SPSS provide excellent option to how to evaluate that one. Look at this. Analyze, regression analysis, linear regression. Again, exactly same format, right? First block, 2 independent variable. Second block, additional independent variable, right? Statistic, you need to ask, look at this, R score change. R score change, actually you able to evaluate those R score value improvement is a statistically significant or not, right? This is very important statistic in multiple regression. You have a very nice research question can be answered by this. Continue, click OK again, and in your regression output include this part. This is additional part, right? And we never seen it, this one, right? Look at this. R score change from model 0 to 1 is 0.31. Yeah, this is not so much funny, but R score change to 1 to 2. See, R score value is improved 0.087. 0.087 amount of what? Nearly 9% of what? R score value. 9% of statistical explainability improved, right? But again, how many additional independent variable? You're adding x3. So additional 1 independent variable, you improved 9%. What is the important question? Whether that 9% is statistically significant or not has been answered by this. Again, this p-value or sig value is very, very important. If your research question is what? Given x1 and x2, whether x3s are statistically significant or not, and this p-value plays that particular role. Statistically, we don't have to worry about too much, but this is statistical significance test for the additional 1 independent variable, which is equivalent to what? this particular statistical significance. Again, but in here, you're not easily see this is additional statistical explainability, but this one is what? Oh, our score value improved. So whether that improvement is statistically significant or not. Again, this is very important part of research question. Thank you.